Hi guys, and welcome back to another video. This one will be about fission and fusion. Nuclear fission is a type of nuclear reaction that is used to release energy from large and unstable atoms such as uranium or plutonium by splitting them into smaller atoms. Spontaneous fission, which is unforced, rarely happens. Usually, the nucleus has to absorb a neutron before it will split. When the atom splits, it forms two new lighter elements that are roughly the same size and that have some energy in their kinetic energy stores. 2 or 3 neutrons are also released when an atom splits. If any of these neutrons are moving slow enough to be absorbed by another nucleus, they can cause more fission to occur. This is called a chain reaction. You may have to draw a complete diagram to show a chain reaction in the exam, so make sure you're happy with fission reactions. The energy not transferred to the kinetic energy stores of the product is carried away by gamma rays. The energy carried away by the gamma rays and in the kinetic energy stores of the remaining free neutrons and the other decay products can be used to heat water, making steam to turn turbines and generators. The amount of energy produced by fission in a nuclear reactor is controlled by changing how quickly the chain reaction can occur. This is done using control rods, which are lowered and raised inside a nuclear reactor to absorb neutrons, slow down the chain reaction, and control the amount of energy released. Uncontrolled chain reactions quickly lead to lots of energy being released as an explosion. This is how nuclear weapons work. Nuclear fusion is the opposite of nuclear fission. In nuclear fusion, 2 light nuclei collide at high speed and join or fuse to create a larger, heavier nucleus. For example, hydrogen nuclei can fuse to produce a helium nucleus. The heavier nucleus produced by fusion does not have as much mass as the 2 separate light nuclei did. Some of the mass of the lighter nuclei is converted to energy and released. Fusion releases a lot of energy, more than fission for a given mass of fuel. So far, scientists haven't found a way of using fusion to generate energy for us to use. The temperatures and pressures needed for fusion are so high that fusion reactors are really hard and expensive to build.